continuing to talk about how to graph systems of inequalities. We're going to put systems of inequalities. All right? Now, I'm going to highlight this inequality in blue, and I'm going to highlight the other one in this awesome magenta color. Now, these are easy. Why? Because they're already in what form? Slope-intercept form. But you're right. I know what you meant. Now, how about this? Could you tell me what the slope is equal to in this? Close. Not 1/4, but negative 1/4. Now, why do people pause on this? Because they don't see what? They don't see this as a 1 over a 4. But if you see an x, automatically assume what coefficient or what number's in front of that x? A 1. Can you realize that for the rest of your life?
I can try.
No. Do or do not. There is no try. Little green dude said that. You guys know that's right now. All right. So, what is the b value? What is my y-intercept? 1. So let's graph this. We're going to start right here at the y-intercept of 1. And how do we apply a negative 1/4 slope? We have to go down 1 and over. Now, you're right. We could go up 1 and over 4 to the left. But we're going to start. We're going to start this graph from the y-intercept right here at the end. Going down 1 over 4. And we're going to put a point. And then, Maddie, we're like, oh, we can't go down 1 and over 4. So over here, we can go up 1 and over 4 to the left and put a point. Now, you guys also notice we have this symbol right here, which represents the greater than or equal to inequality symbol. Now, the greater than or equal to symbol, say that again. Solid line. So, yes, we're going to graph a solid line. And what else? We're going to shade where? Shade above. So here's how we're going to do it. We're going to graph a nice solid line first. Notice it's not dashed, no dots, because anything on that line is an answer, which means a point here, a point here, a point here. All those points are a part of that answer, and any answer that is above it. So yes, we need you to shade gently, shade above. My pen for my board was not doing well today, but thank goodness for Mr. Lappick, because he had a backup pen in his desk, and now everything works beautifully once again.
Why is the pen always on?
Well, it's not always. It wasn't holding its charge. Okay?
Oh, you have to charge.
You have to charge it, yes, and it wasn't holding the charge. But now it's working, so we're happy.
You're happy.
I'm happy. Maybe you're not happy, but I'm happy. Now, what's the slope of the magenta line? 3. Now, what does that mean? That means we have a 3 over a 1, which means we go up 3 units and over 1 unit. What's our y-intercept? Negative. So let's start at the y-intercept, right here at a negative 1. And then from that point, we're going to go not 1, not 2, but up 3 units and over 1, and we're going to put a point. We're going to go up 3 units and over 1, and we're going to put a point. Now, this is not the greater than symbol. This is a less than symbol. So we have a less than symbol. So there's 2 things that we need to know about the less than symbol. Yeah, it's going to be dotted. And shade under. Shade below. We're going to be shading below the line. All the y values that are less than this. First, we got to make a nice dotted line. I know yours is not as easy as mine to make a nice dotted line.
Yeah.
Mine's a little bit easier.
Oh, okay.
A little bit.
A little bit, just a tad. Okay, a lot. It's a lot easier. Now, this is where it gets kind of tricky. It's pretty easy to see if that was the line to shade underneath it, right? Mm-hmm. And if it was going this way, pretty easy to see that this part is underneath, all right? But I want you guys to understand that this area right here is a above the line, and this area right here is technically below the line. So we're going to shade everything below the line, and this area is technically the below line part. And as you do this, I want your brains to recognize where the two shaded parts meet, because that is your area. That is your solution region. That's where all the answers are. It's kind of a shady region. So the solution region is right there. Which, now, here's what you need to understand also. Is this point right here on this line considered to be a solution? Yes, because it's included in the line. But if I said, is this point right here a part of the solution, your answer would be no, because it's dashed, it's dotted. It doesn't include that point. Now, if you go slightly inside of it, like right there, yeah, that works. That doesn't work. That doesn't work. But anything inside this region, anything inside that region or on this line works. Okay? Because this is the equal to part. Okay? That's the equal to part. So that's number 6. Now we're going to do number 9, which is slightly more difficult because it's not in slope-intercept form. So let's go. Once again, let's go down to number 9 and take a look at this. And that'll be the end of this particular video. If you are not able to get this concept from watching this video series, I don't know what else to do.
I cannot help you.
All right? You're going to have to find somebody else smarter than this guy to help your brain recognize the patterns. So, no, it's not. There's many people smarter than me. The more you know, the more you realize how much you don't know. So, here we go. Right now, there's 2 ways to do this. I'm actually going to do the traditional method, not the non-traditional method. What I'm going to do is I am going to solve for y. So here's what I have. I have x minus 2y is greater than 6. Now, to solve for y, we have to isolate all of the y variables, which means this pesky little x, we got to get rid of. How do we get rid of an x? That's right. Now, some people might say, no, you don't. You do additive inverses. Well, you know, that's okay. We're just going to say, you can say subtract x from both sides, and I'm not going to punish you. All right? Now, these right here are.
You swear to it?
I swear, I will not punish you.
Okay.
These are additive inverses. So, yes, those cancel out. So, what are we left with, Maddie? We're left with a negative 2y is greater than. Now, rearrange it where I like it. Close. Yes, good. We're bringing all of the x's up front because we're trying eventually to get into slope-intercept form. Now, oh, close.
-2.
Yes, we have to divide. We have to divide by a negative 2. Now, whenever you guys divide by a negative, a really annoying sound should go off in your head to let you know to do something. Flip the sign. All right? Because whenever you divide by a negative, this sign that was greater than is now less than. And a negative divided by a negative is a positive. And a positive divided by a negative is a negative. But yes, I don't like it like this, do I?
Why negative? Wait, what?
Where did you get lost?
Oh, no.
You got it? Okay. Y is less than. We're going to write the slope of the line. So anytime you see x divided by 2, yes, you guys are making a lot better connections. I heard that a lot of people, hey, it's going to be a half. It's going to be a half. That's good. All right? That's what you want to be able to do. So right here. Here is our line. What is our slope? Yes, it's a half. What's our y-intercept? We're at a... You could leave it as x over 2. As long as you understand that your slope is a half, you can leave it as x over 2. I'm trying to get everybody to be able to understand that x divided by 2 is the same as multiplying by a half. Dividing a number by 2 and multiplying by a half is the exact same thing. Up 1 over, yes, up 1 over 2. So now we're going to plot our line. If I'm going too fast, you can always pause me on the video and write things down and catch up. All right? By the way, that's what the papa tomato said to the baby tomato when he was lagging behind. He said, son, catch up. none of you in here. So here we go. There's -3. We're going to go up 1. We're going to go over 2. We're going to put a point. Up 1, over 2. Put a point. Down 1, over 2. Put a point. Down 1, over 2. Put a point. Now, what is it? I'm not going to write down the rules for less than because you already did that. What are the rules for the less than? And dotted line shaded below. So here we go. Make a nice dotted line going through all those points right there. And then you're going to shade everything below the line. And I appreciate all of those people out there that are paying attention and working on this and getting this done like they're supposed to be doing. Not mentioning any names. All right. Not mentioning names, but I'm looking at somebody right now, and then everyone I'm looking at, I'm just not going to throw your name out on YouTube. All right. So, the next part, we need to do the other line. We've got one line done. We've got one more to go. No, we don't, because it's going to be a positive 4y. But we still have to solve for x. So how do we solve for x once again? What are we going to do? Do the additive inverses. So that zeroes out. Okay, here's my inequality sign. So what do we have left? We have a 4y, bring that down, is less. Now, how do I want you guys to rearrange this? I like it. -x minus 4. Divide everything by a 4. Now, let's think about this. If we divide everything by 4, these 4's cancel out. We're left with y is less. Now, if I have a -x over 4, what does that become? What's the slope? Close. That's right. -1 over 4x, and -4 divided by 4 is a -1. There's my line. My slope is -1/4. My y-intercept is a -1. So right here at a -1, you're going to put a point, and then you're going to go down 1 and over 1, 2, 3, 4. I'm out of room. What could I do? I could go up 1 and over 1, 2, 3, 4, and put a point. Once again, we have less than, don't we? Less than is going to be a dotted line and shaded below. So I got to make a nice dotted line going through all of those points. I'll try to do it again. There we go. And now I have to shade everything below. Now this one's a little bit different than the last one. The last one we had some points on the line that were solutions. Because some points were on the line that, remember, it was equal to, those points were solutions. Here, any point, everybody, any point that's on the line is not considered to be a solution. It has to be just this region. Every number that's a solution has to be in this area right here. So once again, label this as your that's the region right here. That's your solution. That point, that point, that point, that all these points are not considered to be solutions. Why are they not solutions? Because it's not equal to, right? If it was equal to, that's when you have the solid line. And that's the end of this particular video.